In this video, we are going to talk about what is an inverse of a function and how do we find that inverse. Okay, so let's say we have a function y is equal to f of x and we have to find its inverse. Let's say we are keeping x here and x equal to f inverse of y. So in this case, f inverse of y would be the inverse of the function y is equal to f of x. So there's this an important question that every function will have its inverse. So the answer is no. Only one function or one-to-one function will have its inverse. So let's say we have a function y equal to x. Question is it 1, 1? So 1, 1 means for each x, there is a unique y. Okay, let's try to understand this through picture. Here we are taking axis and here we are putting y values. So for this function y equal to x, if we take x is equal to 1, the answer is 1. If we take x is 2, the answer is 2. If we take x as -1, the answer is -1. So for each x, we are getting a unique y. So this kind of function will be called 1, 1. So y equal to x, yes, it is 1, 1. So if it is 1, 1, it will have its inverse. If it is 1, 1, y equal to x will have an inverse function. So let's take the example y equal to x square. We want to know if y equal to x square will have inverse. So for that, we will have to check that if it is 1, 1 or not. If it is 1, 1, yes, it will have inverse, and if it is not, then it will not have an inverse. Let's check it again through this picture to decide that if it is 1, 1 or not. So we take x equal to 1 and the answer is 1. When we plug 1 in x square, so 1 square is 1, so we get y as 1. When we take -1 and we plug -1 in x square, -1 whole square is 1, so we get again 1. So we can see that this function is not 1, 1 because two different x's are giving the same y value. So we will say that y equal to x square is not 1, 1. We can write it like this also. So it will not have inverse. So inverse of a function must exist if and only if the function is 1, 1. Let's try one more example to see that if y equal to x cube will have an inverse function. For that, it must be 1, 1. So let's check that if it is 1, 1 or not. We take x values and plug in the function and we get the y values. Okay, so let's take x is equal to 1. When we plug 1 in x cube, 1 cube is 1, so answer is 1. When we take -1, the answer -1 cube is -1, so answer is -1. When we take 2, the answer is 8. So looks like y equal to x cube is 1, 1, so it will have its inverse. Y cube is 1, 1, so its inverse will exist. So this is settled that if a function is 1, 1, it will have an inverse. If it is not 1, 1, it will not have an inverse. Let's try to find now how to find the inverse of a function. Let's take the example for y equal to x cube minus 1 to find out the inverse of this function. First of all, the question is, will the inverse of this function exist or not? So for that, this function y equal to x cube minus 1 must be a 1 1 function, and you can check that it is 1 1. So how do we find the inverse of a function? To find the inverse of a function, please keep this before you: y equal to f of x, then x could be written as f inverse y. So why have I written this on the side? So this should be my goal. I have to take x out of this equation and keep it on the side, and everything else on the another side here, this would be called f inverse of y. So coming back here, y equal to x cube minus 1, my goal is to find the x, keep it on the side, everything else on the other side would be called f inverse y. So let's try to find the x. So coming back to y equal to x cube minus 1, I'm bringing 1 on the other side. Y plus 1 equal to x cube. Again, my goal is to keep the x only on one side. So on both sides, I will take the power 1 over 3. Why have I taken the power 1 over 3 on both sides? Because I wanted to keep this x. So 3 cancels out with this 3, so you have x. Remember that this is what we said, that x should be separated out. So we have done that. So if this is x, recalling this, x is equal to f inverse y. So x as it is, we are going to call y plus 1 to power 1 over 3 as f inverse y. So we are comparing x with x is equal to x, and this thing now is f inverse of y is equal to y plus 1 to whole power 1 by 3. So this gives us f inverse y is equal to y plus 1 to power 1 over 3. So we have found the inverse of our function, which is this one. But conventionally, when we define the function, we always define it in the form y is equal to f of x, where x is an independent variable and y is the dependent variable. So just to keep that same convention, what we are going to do is, after finding the inverse, which is f inverse of y equal to y plus 1 to whole power 1 by 3, we are going to replace y with x. So this gives us f inverse of x is equal to x plus 1 to power 1 over 3. So that is the inverse of which function? It is this function y equal to x cube minus 1. So we had the function y equal to x cube minus 1, and we found its inverse, f inverse of x equal to x plus 1 to power 1 over 3. Okay, we can check that if for y equal to x cube minus 1, the inverse is x plus 1 to power 1 over 3. So if it is the right inverse that we have found, so to check that, what we are going to do is, first of all, y equal to x cube minus 1, we usually call y as f of x. So f of x is equal to x cube minus 1, and we have found that f of x inverse is f inverse x, and in our particular case x cube minus 1 has the inverse x plus 1 to power 1 over 3. So to check if f inverse x is the right inverse of f of x, we are going to compose f with f inverse x, and after composition, if we get only x, we will say that f inverse x that we have found here, it is the right inverse function. of the given function f of x equal to x cube minus 1. Let's try to understand this through numbers. If we have 2 and if I multiply 2 by its multiplicative inverse, so 2 cancels out with this 2 and I get back only 1. Right? The same way, if I multiply f with its inverse, then this f inverse and f will cancel each other out and I would only have x. Only if this f inverse is the right multiplicative inverse of f, right? So let's check in our particular case if f inverse x that we got here is the right inverse of f of x. So let's compose composition f inverse of x. So we did the composition in one of the previous videos. So composition is opened like this. Node is changed into parentheses. Then the inside function first, which is f inverse x, which is x plus 1 to power 1 by 3. And then we write down the outside function. Outside function is f, and f we will write f completely, but wherever there is x in f we will leave the space for it. So our function was x cube minus 1. We will not write x, we write cube minus 1, and in the missing space we will put this argument, which is x plus 1 to power 1 by 3. So basically we have x to power, so basically we have x plus 1 to power 1 by 3 whole power 3 minus 1. So this 3 cancels with this 3. We have x plus 1 minus 1, plus 1 cancels out with minus 1, and you have x only. That's what we said, that if a function and its inverse composition gives you x only, you will say that you have found the right inverse, and that is what is happening here. So we'll say that f inverse x that we have found, which was x plus 1 to power 1 over 3, is the inverse, the right inverse of the function y equal to x cube minus 1. So this is how we find the inverse of a function. So the inverse of a function will exist only if the function is 1, 1.